All right. Okay, so this question is asking us to determine the type of growth pattern that is noticed. Um, we are to identify the total number of squares in step 6, and we're also to write an expression that will give us the total number of squares in this pattern. So the way I like starting out is I like to focus on the total number first because I think it helps me to tell um, whether we're having linear or exponential or quadratic growth. So step 1 has 1 square. Step 2 has, oh, that's 4 in total. Step 3 has, that's 9 in total. Next, I want to look at how the numbers are changing because that's an indication for me. Okay, so 1 to 4, that's a plus 3. 4 to 9, that's a plus 5. I wonder if the pattern continues. So let's look at what I notice that is staying the same. So there's a 1 square. There's a 1 square. There's a 1 square. And then what is changing in this? So let me write this down. What is staying the same? So stays the same. There is a plus 1 square. And then let's look at what's changing. So what's changing? Oh, we have growing squares. That's changing. Oh, we have growing squares. Is this enough to kind of establish a pattern? So what would the step 4 look like? So let's write what we notice is changing. And the way I think about it is the size of squares. And I think about that as n times n. So I like to establish the next one because sometimes I think 3 is just not enough to tell exactly what's going on. So I'm going to do step 4. And this looks like it would have been a 2 by 2. That's a 3 by 3. So I'm thinking my step 4 is going to have a 4 by 4 with a little extra piece. So I'm going to draw a 4 by 4. And then I'm going to get rid of one of my squares because that's what I'm noticing in my pattern. So this one right here goes. But you know what? I have my little extra right here. So according to what's going on, yeah, that's what stays. And this is what is changing. All right, how does this connect to the numbers that I already have? So the total number of squares in step 4 is going to be, oh, how many squares is that in total? That is 16. And then to go from 9 to 16, that's a plus 7. Let's clean that up. So this is a plus 7. Now I noticed that even though the rate of change is not the same, there is a particular pattern with how the numbers are changing. So from 3 to 5, that is a plus 2. From 5 to 9, 5 to 7, sorry, that is a plus 2. So what can I say? What do I notice is that the change in the rate of change is constant. So I'm just going to write that. Change in rate of change is constant. How is that helpful? So we want to write an expression that gives us this pattern. So a table is very useful. So I'm going to construct my table. My X is going to represent the step number, and the Y is going to represent the total. So this is step number, and this is total squares. All right, so on step 1, I have 1 square. On step 2, I have 4 squares. On step, that should be 2. Step 2, I have 4 squares. Step 3, I have 9 squares. And on step 4, I have 16 squares. So what do I notice based on the pattern? It's kind of like I have a square that is not finished, but if I should bring this extra square around, it makes or completes my square. And for me, that's going to be really helpful information. So if I go there, that becomes a full 2 by 2. If I bring this around here, that becomes a full 3 by 3. If I bring this around here, that's going to become a full 4 by 4. So what do I notice is that my Y is going to be equal to the dimensions of the square. So it's n times n, or Y is equal to n squared. Now, if I want to find the 6th step, or step 6, I'm going to use the step number 6 squared, which is equal to 6 times 6. So that is equal to 36.